LangGraph implements a custom streaming mechanism to integrate external LLM clients, enabling real-time token-by-token output handling within its graph-based execution framework. This approach leverages asynchronous generators to process and yield LLM response chunks, maintaining state consistency while supporting dynamic role assignment during streaming operations. The code demonstrates how to establish an asynchronous streaming pipeline with an OpenAI client, where token chunks are captured and propagated through a graph node structure. You'll see the initialization of an Async OpenAI client, a streaming token handler that processes delta updates, and a tool function that integrates this streaming capability into LangGraph state management system. The implementation showcases how custom streaming logic can be embedded within graph nodes, while maintaining compatibility with LangGraph's state graph architecture.
Import operator. Import JSON. From typing, import typed dict. From typing extensions, import annotated. From LangGraph, graph import state graph start. From OpenAI, import async OpenAI. OpenAI client equals async OpenAI. Model name equals GPT-4 1 mini. Async def stream tokens model name. SDR messages, list dict. Response equals await OpenAI client. Chat completions, create. Messages equals messages. Model equals model name. Stream equals true. Role equals none. Async for chunk and response. Delta equals chunk, choices, delta. If delta role is not none. Role equals delta role. If delta content. Yield role content, delta content. Hash this is our tool. Async def get items place. SDR. Use this tool to list items one might find in a place you're asked about. Writer equals get stream writer. Response equals async for MSG chunk and stream tokens. Model name. Role, user. Content. Can you tell me what kind of items? I might find in the following place. Place. List at least 3 such items, separating them by a comma. And include a brief description of each item. Response plus equals MSG chunk content. Items chunk. Return response. Class state type dict. Messages, annotated list dict, operator add. Hash this is the tool calling graph node. Async def call tool state. AI message equals state messages -1. Tool call equals AI message tool calls -1. Function name equals tool call function name. If function name equals get items. Raise value error, tool function name not supported. Function arguments equals tool call function arguments. Arguments equals JSON, loads function arguments. Function response equals await get items, *** arguments. Tool message equals tool called, tool call ID. Role, tool. Name, function name. Content, function response. Return messages, tool message. Graph equals state graph state. Add node call tool. Add edge start, call tool. Compile.
This code demonstrates async custom streaming with an external LLM client in LangGraph, focusing on real-time token streaming and tool integration. The pattern uses OpenAI's Async API to stream tokens from GPT-4, 1 mini, processing them incrementally while maintaining state through a state graph. The implementation showcases 2 key components. Stream tokens handles the low-level async streaming from OpenAI's API, yielding individual message chunks with role metadata, while getItems acts as a tool that consumes this stream, aggregates the response, and uses getStreamWriter to emit custom streaming data. The callTool node processes tool calls by extracting function arguments, invoking the appropriate tool, and returning the response in the expected format. This approach enables real-time updates during tool execution, crucial for responsive LLM applications. The trade-off is increased complexity in managing async streams and state, but it provides superior UX by showing progress incrementally. The pattern is particularly valuable when integrating external LLM clients that don't follow LangChain's standard interfaces, offering flexibility while maintaining LangGraph's streaming capabilities. Let's break it down.
Import operator.
Imports Python's built-in operator module, which provides functions corresponding to standard operators like arithmetic and comparison operations.
Import JSON.
Imports Python's built-in JSON module for JSON serialization and deserialization operations.
From typing, import typed dict.
Imports typed dict from the typing module, which provides a way to define dictionaries with specific key types and value types for type checking and documentation purposes.
From typing extensions, import annotated.
Imports annotated from typing extensions for adding metadata to type hints.
From LangGraph, graph import stategraph start.
Imports stategraph and start from the LangGraph graph module. Stategraph is a class for constructing stateful graphs, while start is a constant representing the entry point in a graph workflow.
From OpenAI, import Async OpenAI.
Imports the Async OpenAI class from the OpenAI package, providing asynchronous access to OpenAI's API for non-blocking LLM interactions.
OpenAI client equals Async OpenAI.
Creates an asynchronous client instance for interacting with OpenAI's API. The OpenAI client variable holds this client, which will be used to make non-blocking HTTP requests to OpenAI services. This is the standard way to initialize the OpenAI Python library for async operations.
Model name equals GPT-4 1 mini.
Assigns the string GPT-4 1 mini to a variable named model name, creating a reference to this specific model identifier for later use in the code.
Async def stream tokens model name. SDR messages, list dict.
Defines an asynchronous function named stream tokens that accepts two parameters, a string model name and a list of dictionaries messages. The function is designed to handle streaming operations, likely for processing tokens from a language model in real time, given the context of LangGraph's streaming capabilities. The async keyword indicates this function will run asynchronously, allowing other operations to proceed while waiting for token generation.
Response equals await OpenAI client. Chat completions, create. Messages equals messages. Model equals model name. Stream equals true.
Makes an asynchronous call to the OpenAI API's chat completions endpoint with the provided messages and model name, enabling streaming mode to receive the response incrementally as tokens are generated. The messages parameter contains the conversation history. Model name specifies which LLM to use, and stream equals true ensures the response is delivered as a continuous stream rather than waiting for full completion.
Role equals none.
Initializes a variable named role and assigns it the value none, indicating it currently holds no specific role or value.
Async for chunk and response.
Iterates asynchronously over chunks in the response stream. This is a standard async for loop that processes each chunk as it becomes available from the response object, enabling real-time handling of streaming data. The loop will yield control back to the event loop between iterations, allowing other tasks to run while waiting for the next chunk.
Delta equals chunk, choices, delta.
Extracts the delta property from the first choice in the chunk object's choices array and assigns it to the variable delta. This captures the incremental update or difference in the streaming response, which is essential for processing real-time token streams or state changes in LangGraph streaming system.
If delta role is not none, role equals delta role.
Checks if the delta object has a non-none role attribute and assigns its value to the role variable if true. This is a conditional assignment that only updates role when the delta contains role information, preserving any existing value when delta role is none.
If delta content, yield role, role content, delta content.
Checks if delta content exists and is truthy, then yields a dictionary containing the role and content from the delta object. This is part of a streaming mechanism where each chunk of content is immediately passed downstream as it becomes available, rather than waiting for complete accumulation. The yielded dictionary follows a standard message format with role and content fields.
Async def get items place, SDR. Use this tool to list items one might find in a place you're asked about.
Defines an asynchronous function named getItems that takes a string parameter place and returns a string. The docstring indicates this function serves as a tool to list items typically found in a specified location.
Writer equals getStreamWriter.
Calls getStreamWriter and assigns the returned value to a variable named writer. This retrieves a stream_writer object that can be used to send data to a stream, likely for real-time updates or output handling in the LangGraph streaming system.
Response equals
initializes an empty string variable named response that will store text data. This creates a mutable container for accumulating output, likely to be populated later in the code flow. The variable starts with 0 length and no content.
Async for MSG chunk and stream tokens.
Iterates asynchronously over message chunks from a token stream. The stream tokens function yields individual message chunks as they become available, allowing real-time processing of streaming data. Each MSG chunk represents a discrete unit of data from the stream, enabling progressive handling of the output.
Can you tell me what kind of items? I might find in the following place. Place.
Constructs a string that asks about the types of items that might be found in a specific location, with the location dynamically inserted using an f-string. The string is a question prompt that combines static text with the variable place, which is interpolated into the final output. This creates a complete sentence like, "Can you tell me what kind of items I might find in the following place?" Kitchen, where kitchen would be the value of the place variable.
List at least 3 such items, separating them by a comma.
Instructs the system to generate a comma-separated list containing at least 3 items. The output format requires items to be separated by commas, with no additional formatting or structural elements specified. This is a direct formatting instruction for list generation.
Response plus equals MSG chunk content.
Appends the content from the MSG chunk dictionary to the response variable. This accumulates streaming message chunks into a complete response string.
Writems chunk.
Calls the writer function with MSG chunk as the argument, passing the message chunk data to be processed or output by the writer function. This is a direct function invocation, where MSG chunk is the input being sent to the writer for handling.
Return response.
Returns the response variable's value to the caller. This is a standard return statement that exits the current function or method, passing back whatever data is stored in response at that point in execution.
Class state type dict
defines a state class that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a typed state container where each field's type can be explicitly declared, enabling type checking and IDE support for state management in the application.
Messages annotated list dict operator add
declares a variable named messages with type annotation indicating it's a list of dictionaries. The annotated wrapper specifies that this list should be combined using operator add, meaning when multiple instances are merged, their lists will be concatenated rather than replaced. This is commonly used in streaming contexts where message collections from different sources need to be accumulated.
Async def call tool state
defines an asynchronous function named callTool that accepts a single parameter state of type state. The function is declared with async def, indicating it will perform non-blocking operations, and the state parameter suggests it will work with some state management object, though the specific implementation details of what the function does with this state are not visible in this segment.
AI message equals state messages -1
retrieves the most recent message from the messages list stored in the state dictionary and assigns it to the variable AI message. The -1 index accesses the last element in the list, which represents the latest message in the sequence.
Tool call equals AI message tool calls -1
retrieves the most recent tool call from the AI message dictionary by accessing the last element of the tool calls list. The variable tool call is assigned this value, which represents the latest tool invocation in the sequence.
Function name equals tool call function name
extracts the function name from a tool call dictionary by accessing the nested function key and then the name key within it. The result is assigned to the variable function name.
If function name equals get items, raise value error, tool function name not supported.
Raises a value error if the function name is not getItems, enforcing that only the getItems tool is supported in this context.
Function arguments equals tool call function arguments
extracts the arguments from a function call stored in the tool call dictionary. The tool call dictionary contains a nested structure where the function details are stored under the function key, and the arguments for that function are accessed via the arguments key. This line retrieves those arguments and assigns them to the variable function arguments.
Arguments equals JSON loads function arguments,
parses the JSON string stored in function arguments, and assigns the resulting Python object to the variable arguments. This converts a JSON formatted string into a native Python data structure, like a dictionary or list for programmatic use.
Function response equals await get items *** arguments.
Calls the getItems function asynchronously with keyword arguments unpacked from the arguments dictionary, then awaits its completion and assigns the returned value to function response. This demonstrates an async function call where parameters are dynamically passed using dictionary unpacking.
Tool message equals tool called tool call ID.
Creates a dictionary named tool message with a key tool called. Assign the value from tool call ID. This establishes a reference to a specific tool call by its unique identifier, likely for tracking or responding to that particular tool invocation.
Role tool
sets the role to tool in a dictionary or JSON-like structure, indicating this entry represents a tool configuration or definition within the system.
Name, function name.
Assigns the string value of function name to the key name in a dictionary. This creates or updates a dictionary entry where the key is the literal string, name, and the value is the variable function name.
Content, function response.
Assigns the value of function response to a key named content in what appears to be a dictionary or JSON-like structure. This line is setting up a data payload where the response from a function will be stored under the content field, likely for further processing or transmission.
Return messages, tool message.
Returns a dictionary with a messages key containing a list with a single element, the tool message variable. This packages the tool message into a standardized format for streaming output, where the message will be part of the messages stream mode that includes LLM tokens and metadata.
State graph state.
Creates a state graph instance initialized with a state class, establishing the foundation for a graph-based state management system where state defines the structure and initial values of the graph state.
Add node call tool.
Adds a node named call tool to the graph. This node will be part of the graph's execution flow, allowing the graph to invoke the tool when execution reaches this node.
Add edge start, call tool.
Adds a directed edge from the start node to the call tool node in the graph, establishing a direct transition path where execution will flow from the start point to the tool invocation node.
Compile.
Compiles the LangGraph workflow into an executable form, preparing it for execution with all defined nodes, edges, and streaming configurations in place. This is the final step before the graph can process inputs and stream outputs according to the specified mode's state updates, token streams, etc. This implementation showcases LangGraph's custom streaming integration with external LLM clients, specifically demonstrating how to handle real-time token streaming from OpenAI's Async API while maintaining state consistency. The core pattern revolves around two key components. Stream tokens handles the low-level async streaming from OpenAI, yielding individual message chunks with role metadata, while getItems acts as a tool that consumes this stream, aggregates the response, and uses getStreamWriter to emit custom streaming data. The call tool node processes tool calls by extracting function arguments, invoking the appropriate tool, and returning the response in the expected format. This approach enables real-time updates during tool execution, crucial for responsive LLM applications. The trade-off is increased complexity in managing async streams and state, but it provides superior UX by showing progress incrementally. The pattern is particularly valuable when integrating external LLM clients that don't follow LangChain's standard interfaces, offering flexibility while maintaining LangGraph's streaming capabilities.
The tool whispers answers it never hears, streaming tokens from places it never visits.